Then let's go over what hopefully you learned from the Tyler DeWitt video, or at least some of it. So what does REDOX stand for? REDOX. Yes, reduction is half of it. And what's the other half? Oxidation. Yes. Okay, so we're going to have a reduction and oxidation reaction, and that's a lot of a mouthful to say, so we often just say redox. And Tyler talked about the half reactions, which is half of an oxidation and reduction the reaction. And one of the ways of remembering which one is which is this little mnemonic device here, which is Leo the lion says grr. Does anyone remember, or there's another one, oil rig. Does anyone remember what either Leo or oil stand for? Leo or oil? Anyone remember what those are for? Loss of electrons, yeah, or something like that, yes. So if you have Leo, you have losing electrons is, so we have our L, we have our E, and we have our O, oxidation, yeah. Okay, losing electrons is oxidation. So Leo the lion says grr, the other half of that would be, the G stands for gaining, yeah, gaining. And then again, E for electrons is, and I'm kind of running out of room here, reduction. Okay, so we have G, E, R. So Leo the lion says grr. All right. If you like what that mnemonic, that's great. If you prefer the other one, that's also fine. OIL, oxidation. The O. I for is. L for losing. And then we have R for reduction in the rig, reduction. Is, I for is, and G for gaining. I will let you know right now, when I was in high school, I learned Leo the lion says grr, so that's the one I will tend to use. But if you like oil rig better, that's perfectly good, okay? So either Leo says grr or oil rig. Now, the deal is that you cannot, in life, have an oxidation without having a reduction. If somebody is losing electrons, if A is losing an electron, it can't just go flying out into space somewhere. And this is the point at which usually I grab a pen, and the pen is my electron, and then I fling it across the room, and everyone is shocked. But I can't do that, so we just have a boring little old A giving its electron. It can't just fling it out into space. It has to give it to somebody else. So maybe it gives it to a B that has a positive charge and needs an electron. And what you would end up then with is A would end up being A positive because it lost an electron, and B plus would become B. Okay, so that would be your A is losing electrons. So that is oxidation. A is being oxidized. and B is gaining an electron, which is reduction, and so it is reduced. And one thing I want you to notice here is that the oxidation number of A, I've really not left myself enough room here. That's okay. The oxidation number of A in this first one, what is the oxidation number of A there? It's just A all on its own. It is 0. That's right. Any element on its own, the oxidation number is 0. And then down below here, the oxidation number is +1. And so the oxidation number got bigger. Oh, look at that. Oxidation number got bigger. It was oxidized. Yes? And you'll notice that B goes from having an oxidation number of +1, and then it's on its own, so its oxidation number is 0. And so that number got reduced. It got smaller. So that was reduction. Reduction is when the oxidation number gets smaller. And don't worry too much about taking those notes down. They will happen again later in the context of our next step, which is balancing half reactions. All right, so this worksheet here, you have this entire thing in the assignment. It is all filled out for you. So if we're going along and you don't want to write anything down, you don't have to, especially for the rules. The rules would take a long time to actually write down. So we are going to just take a look at these rules and then apply them to some examples. And like I said, those examples are all written out for you in the worksheet, the copy of this that you have in the assignment page. Okay? All right, let's see. So half reaction, there's a series of steps that you're going to do. You are going to balance all the elements except hydrogen and oxygen. We're going to leave hydrogen and oxygen for later. And we do this in the way that we normally do to balance equation, and that is by changing the coefficients. Okay. And Hebden tends to call these the major atoms, and the major atoms are those non-oxygen, non-hydrogen atoms. So anything that's not oxygen or hydrogen, Hebden calls those the major atoms, and we balance those by using coefficients. Step number 2, we balance oxygen by adding water. Okay, so all of these reactions are going to take place in aqueous solution, and so there will be lots of water hanging around because it is the solvent. All right, and then we're going to balance the hydrogen atoms, and we will do that by adding H plus ions. And what that means is that a lot of these reactions will actually take place in acidic solution, and they won't actually happen unless you have some acid present. So yeah, so first we balance our major atoms, then we balance oxygen, and then we balance hydrogen. And we balance those by adding water and hydrogen ions, H plus. And then finally, because these are involving a change in the number of electrons, we need to balance the electrical charge by adding electrons, okay? And you'll notice here we balance major atoms first, then oxygen, and then hydrogen, and then the charge. So you can remember this as major OH says charge, or major hydroxide, because OH is hydroxide, says charge. Okay, it's like the military or whatever. Okay, so if you follow those 4 steps, you will be balanced in acidic conditions. There are 3 more steps to balance in basic, but we're not going to look at those just yet. We'll leave that till we do an example. Let's just use those first 4 rules to balance this example. Mn3 plus goes to MnO4 minus, in acidic conditions. Okay, so step number one, we are going to balance anything that is non-hydrogen or non-oxygen. And in this case, the thing that is non-hydrogen and non-oxygen is manganese. Are the manganeses balanced? Yes, they are. So step number one is done. We have one manganese on the one side and we have one manganese on the other side. So we don't have to do anything with that. Step number two, we are going to balance who comes next after our major atoms. O and then H. So in this case, it's going to be oxygen. And we balance it by adding, do we just add plain old oxygen? We balance it by adding water. Thank you, Deborah. Everyone else is asleep this morning. It's okay. Okay, so we're going to add water. So let's just write out our reaction here. We've got Mn, or half reaction rather, goes to MnO4 minus. So we have 4 oxygens here. And so we are going to add 4 H2Os because that's going to give us 4 oxygen on the left-hand side. Okay. Step number 3. We balanced oxygen and now we will balance hydrogen, yes. And we balance that by adding hydrogen, not just plain old hydrogen, but hydrogen plus ions. Okay, so we have 4H2O plus Mn3 plus. I'm just rewriting the last step here. Gives us MnO4 minus. And we have 4 and 2 gives us 8 hydrogens over here. So we need to add 8 hydrogens to the other side. So that's going to be 8 H pluses. And then finally, step 4, we are going to balance. Let's see, we did major OH says, what do we balance last? Everybody think about it. Charge! Yes, excellent. Major OH says charge, and we balance that by adding, what do we add? Excellent. Even if you're not typing it in, make sure you're thinking it to yourself, because the more times you repeat this to yourself, the better off you're going to be. You're sitting in your house, you can say it out loud to yourself. I sit in here and just talk to myself all morning, and I sound like a crazy person, but that's okay. I just close the door so my family doesn't have to hear me. Okay, so writing down our step, we had 4 H2O. Oh, I'm going to give myself a little more room. 4 H2O plus Mn3 plus goes to MnO4 minus plus 8H plus. And for this one, I truly recommend that you write down your charge. So over on the left-hand side, we have a 3 plus charge. So I'm going to write that down and put a circle around it. And over on the, sorry, that was the left-hand side. Over on the right-hand side, we have a -1, and we have 8 positives. Okay, so over on our right-hand side, we have -1 right there, And then we have 8 positive, so we're going to add that up, positive 8. And -1 plus positive 8 gives us positive 7. So we are going to balance the charge by adding electrons. To which side will we add electrons? And remember, electrons have a negative charge. Okay, so if electrons have a negative charge, we have to add them to the side which is too positive, which has too much positive charge. Add to the side which has too much positive charge, or the side that is more positive. We'll make it less positive. Okay, so we are going to add them to the right. So what we'll end up with then is we will end up with, I'm going to add in my 3 electrons here. No, that's not going to work. I need to add, how many electrons do I need to add? 4. Yeah, 4 electrons. And if I had written all over it like this, I would probably rewrite my answer because it's pretty ugly. I'm going to do that anyway because now I'm going to ask you a different question about it. Okay, so we have this. Now the second part of the question, I'm going to ask you about this. Is this half reaction, an oxidation, or a reduction? Is this oxidation, sorry, is this half reaction, an oxidation, or a reduction? Think about that for yourself. Take a moment. Remember, Leo the lion says, grr. Okay, so we can actually look at this from 2 perspectives. Okay, we can say my electrons are coming out of the reaction. Okay, so the electrons are going out. And if they're going out, that would be the same as the electrons are being lost. They were in these chemicals over here, and now they're not in these chemicals over here. Okay, they are separate now from those chemicals. So the electrons have gone out, so we have lost electrons. And if we lost electrons, that is oxidation. Or you can say losing is oxidation is losing. Okay, the other way to look at it is you can look at your manganese, and you can say manganese on the right-hand side, its oxidation number is 3+. That one's really easy, right? On the right-hand side, we have MnO4-, and the oxidation number of manganese there, well, we have 1 manganese, and we have 4 oxygen, and that's going to equal our total charge, which in this case is -1. So we are looking for manganese. Oxygen is -2, has an oxidation number of -2. And so that gives us manganese -8 equals -1. So that means that manganese is equal to +7. So the oxidation number of manganese in MnO4 is +7. So we are going from 3 plus to 7 plus. The oxidation number got bigger. So if the oxidation number gets bigger, that is oxidation. So you can choose which way to look at it, but if you have already balanced the half reaction, it's kind of nice just to be able to go, oh, look, the electrons came out, it lost electrons. And therefore, it is an oxidation. Losing electrons is oxidation. And we're going to do this one. So, step 1, balance the major atoms. In other words, the non-hydrogen, non-oxygen atoms. In this case, we don't have an equal number. Here we have 2 I's, and here we have just 1 I on the right-hand side. So we're going to need to put a 2 in here. We balance by using coefficients. Okay, step number 2, we are going to balance. Who comes next? After our major atoms comes oxygen, and we do it by adding who? Water. Okay, so over on our right-hand side, we have 2 times 3 is 6 oxygen. So we need to have 6 oxygen on the left-hand side, so we'll have 6 waters. Maybe I'll put that in red. 6 waters. Plus I2 goes to 2 IO3. This is one of the places where you can go wrong, is just forgetting to do the multiplication when you have a coefficient. Okay, so just don't forget to do that. All right, and our third thing that we're going to do is we are going to balance. After oxygen comes hydrogen, and we do it by adding who? H plus, yes. Okay, so up here, we have 6 times 2, which is 12 hydrogens. So we need to have 12 hydrogens also on the right-hand side. So if we write that out again, that's 6 H2O plus I2 goes to 2 IO3 plus, and let me just make sure I'm doing this correctly. Oh, it's IO3 minus, dang, dang, dang. IO3 minus. Always go back to your question and make sure you haven't lost a charge somewhere. I have a tendency to do that. The only reason I caught it is because I know IO3 minus is an ion. Okay, so we were balancing out our hydrogen, so we need to add 12 H plus over here. And now it's important that I had that charge there, because now last thing we're going to do is we are going to balance our major OH says charge. And we do that by adding electrons. And remember, electrons are negative, so you'll add electrons to the more positive side. Okay, so let's figure out what our charge is here. We have on the left-hand side, oh, I got a charge of 0. Yeah, because water has nothing. I2 has nothing. Over on my right-hand side, I have 2 times -1 is -2. And I have 12 times +1 is +12. So I have -2 plus +12 equals +10. So the right-hand side is more positive, so that's the side we need to add our electrons to. So in step number 4, 6H2O plus I2 goes to 2IO3 minus plus 12H plus, and we need to add, in order to get it to equal 0, that's going to equal 0, which will equal our 0 on the other side. So that's going to be 10 electrons here. And you can check afterwards. It's always a good idea to check because it's so easy to make stupid little mistakes. So for example, if I had left off this little charge here, I would get to the end and things wouldn't quite work out. Things would just be wrong at some point, and I'd be like, oh dear, go back and check your question, make sure, oh, I had a charge. Do I still have my charge? Go through and count. You can be like, okay, I got 12 hydrogens. I got 12 hydrogens. I have 2 iodines. I have 2 iodines. 6 oxygens. Oh, 2 times 3 is 6 oxygens. And my charge, it all equals out. I've got 2 negative plus 12 positive is +10 plus -10 is 0. And on this side, I have 0. All right. What kind of half reaction is this? Is it oxidation or reduction? Okay, yeah, once again, the electrons are coming out. And so as the electrons come out, so we are losing electrons, which is oxidation. Oh, you could be like, oh, electrons go out. That's oxidation. Huh, look at that. Never thought of that one before. Anyway, Leo says GER, L-E-O, L-E-O. Okay, now we're going to go back to our very first page and we're going to look and say, this is how the reaction would work if we were in acidic conditions, because we've got hydrogen right now. But what if for some reason we needed this to happen in basic conditions and we needed it to be in with hydroxide instead of hydrogen? Well, let's go back to our rules. And rules 5, 6, and 7 is going to take the additional steps here. So we are going to, whatever side the hydrogen is on, we're going to look and we're going to say, how many hydrogen do I have? If I have 12 hydrogen, I'm going to need to neutralize 12 hydrogen. So I'm actually going to, if I have 12 hydrogen, for example, I'm going to need to neutralize that with 12 hydroxide, 1-to-1, right? But if I add hydroxide to the side with the hydrogen, that means my reaction is no longer balanced because I'm going to have extra oxygens and hydrogens on that one side. So I actually need to add that number of hydroxides to both sides of the equation. When I do that, my next step is going to be to combine. On the one side where I have both hydroxide and hydrogen, I'm going to combine those to make water. which in this case would be 12 water. And then there will probably be waters on both sides of the equation, possibly some other things on both sides of the equation. So you're going to cancel out anything that needs canceling. So let's go and do that, because reading the steps is harder than doing an example. So let's go take a look at this. So we have balanced this reaction, and we now want to put it in basic conditions. So all we're going to do is we're going to copy down our acidic conditions. 6H2O plus I2 gives 2IO3 minus plus 12H plus 10 electrons. And remember, we want to neutralize all of the hydrogens. So we are going to add 12 hydroxides to this side. These guys together are going to make water, which is going to get rid of the 12 hydrogens and make it basic. But like I said, if you add 12 hydroxides to the right-hand side, this is step 5, add hydroxide to both sides, and it needs to be enough to neutralize the H. So it's going to be the same number as the H plus. Okay, so we've added 12 hydroxides to the right, which means we have 12 extra oxygens and 12 extra hydrogens on the right-hand side of an equation that was previously balanced. So we also need to add over on our left-hand side 12 hydroxides. And then we are going to add that up. So we have 6 water plus I2, and then we're also going to have on the left-hand side plus 12 hydroxides goes to 2IO3. Now remember, these two guys get together and they form water. So that's going to be 12 waters. And then we still have our 10 electrons. And then steps, let's see, step 5, add the hydroxides to both sides. This was also, we also did step 6, which is to make water, which is what we did right here. Okay, we made our water right there. And maybe I should put that like, ooh, what the heck? Dang. Oh. That looks terrible. Good Lord. H2O. And there we go. Okay, so we made our water. And then step 7 is we're going to cancel things out. So step 7, we're going to cancel anything that needs canceling. Do you see anything that is present on both sides? Cancel anything present on both sides. Yeah, we've got water on both sides, right? So we can cancel, well, we've got 6 on the left and 12 on the right, so we can cancel out 6 of them. So those 6 go all the way away. And these ones, we can only cancel 6 of them, so we're going to have a 6 left there. Now, technically, you could just leave this like this. It might be nice if you rewrote it. So rewriting the whole thing, we have I2. Without the waters are now gone, canceled out, plus 12 OH minus goes to 2IO3 plus 6 H2O, and we still have our 10 electrons. And if you go through and check everything at this point, it should still work. And in fact, if you do that, you can say I have 2 I's. Oh, I got 2 I's. I have 12 O's. I have 2 times 3 is 6 O's and another 6 O's. Oh, 12 O's. Excellent. I have 12 H's. 6 times 2 is 12 H's. And as for my charge, oh, look what I did again. I am terrible at dropping charges everywhere. I dropped my IO3 minus again. So, like I said, go back and check because I would have looked at this and gone, oh no, my charge doesn't balance. Why? Oh, it's because I dropped my charge. Over on the left-hand side, I have 12 negatives. And over here, I have 2 negatives. And I have 10 negatives. So it's again 12 negatives. You wouldn't draw all these arrows. You would just check for yourself. But anyway, there we go. All right. We are now going to do MnO4, going to MnO2 in basic conditions, and this time I'm going to show you doing it all in one line rather than writing out step by step by step by step. Okay, so we're just going to do it all in one line. So we have MnO4 minus goes to MnO2. Major, that's anything that's not oxygen or hydrogen. Look, they're equal. Mn, one on one side, one on the other side. Yay! Okay, so next comes oxygen. We have 4 oxygen on the left and 2 on the right. So we're going to need 2 waters over here to give us 4 oxygen on the right as well. Next, we're going to want to balance the hydrogen, major OH. So now we're on the H, and we balance H by adding H plus. We have 2 times 2 is 4 hydrogens. So we're going to add 4 H pluses on the right-hand side. And once we've done major OH, now we're going to do charge. So again, I'm still going to write out on the right-hand side, I have 4 positive from my 4 hydrogens, my 4 H pluses. And to that, I'm going to add a -1 from the permanganate ion. -1 equals +3. If you can do this in your head, God bless you, but every time I try and do it in my head, I get it wrong. So, I really recommend writing out your charges and actually doing the calculation. Leave yourself space in the margins to do that, okay? So on the right, I have +3. Whoa, what happened? Why did it get so small? No. There we go. That's better. Okay. So on the left-hand side, we have +3. On the right-hand side, we have 0. We've done major OH. Now it's charge. We do that by adding electrons to the side, which is more negative or more positive. We add electrons to the side, which is more positive. Yes. So that's going to be our left-hand side. And we're looking at a 3+, and we need to make it equal to 0. So we're going to have to add 3 electrons. And at this point, you guys should be able to tell me, is this an oxidation or a reduction half reaction? It is reduction, yes, because we are gaining electrons. The electrons are going in. And you can actually see on the left-hand side, if we actually look at our oxidation numbers, MnO4, let me just calculate that up here. So we have MnO4, so we have Mn plus 4 O's equals -1. So we have Mn plus 4 times -2 is -8 equals -1. And so we now have manganese is equal to +7, and that's on the left-hand side. So I'm just going to write that up here. It's +7. On the right-hand side, we have Mn, and we have two O's, and its overall charge is 0. So we have Mn plus 2 times -2 is 4, -4, -4 equals 0. So manganese then on the right-hand side is equal to +4, +4. So yes, we gained electrons, but we can also see that our oxidation number was reduced. Oxidation number was reduced. It got smaller. Okay, that's where the term reduction comes from. It's a reduction in the oxidation number. That's where the word reduction comes from. Okay, so two ways you can look at that, but if you've already balanced it, it's easy to look and see, yeah, I'm gaining electrons, so that's reduction. Grr. Leo the Lion says grr. Okay, now where did we get to? We were going to make this basic, right? So to balance an acidic, you can do it all in one line. To make it basic, what are we going to add in here to make it basic? OH, yes. How many OHs do we need to add? We need to add 4. Yes, absolutely. So we're going to have 4 OH minus over here. That's going to give us 4 water when we add it up. And we also have to add to the other side 4 OH minus. Remember, the OH minus must be to both sides. Okay, not just one side, but both sides. And then we can add this up. So we have 3 electrons plus we have 4 hydrogen, and 4 hydroxide is going to give us 4 water plus MnO4 minus, oh look, I remembered my charge, how lovely, goes to MnO2 plus 2 H2O plus 4 OH minus. So we've now added hydroxide. Now we ask if we can do what? Yes, we make water. So actually I skipped saying that step. This is the make water step. Make water. After we've made the water, what do we do next? We cancel. Is there anything we can cancel here? We can cancel out the water. Yeah, there are 2 on one side and 4 on the other, so these ones can go away completely. And this one we can cancel, and we will be left with 2. And if you just want to leave it like that, you can just leave it like that. You could be like, okay, I'm done. Or you could rewrite it if you want to. I feel like your brain is melting now. Okay, just in case, I will add some to the assignment. I'll add a couple of Tyler videos because he balances some stuff, and there's a couple other people who do some good balancing videos, balancing half reactions. Balancing half reactions. So if after your brain has melted, if it stops melting at some point and you're like, I would like a refresher, you can either watch this again, or you can be like, okay, I want to watch somebody else, and you can watch Tyler or some other guy. So I will go add those into the assignment. So your assignment is going to be number 1. You are going to do numbers 1 to 5 and 12 to 14 on balancing half reactions. Worksheet. Number 2, You are going to do numbers, you're going to do numbers 13. No, you did 13. 14 to 20 on the oxidation number worksheet.